Okay, nodal for 200. A hint when you get a nodal problem is that it says the word nodal. So I can label my nodes. Here's A, here's B, here's ground. That's the first step, labeling my nodes. The second step is to write the node voltages. VB, I don't know, so I'm going to write a question mark. And actually, there's one more node here. We'll call it C. The voltage at C is 30 angle 50. 30 volts angle 50 is the voltage at C. VA is unknown, and the voltage at ground is 0 volts. The second step, actually that's the second step, is to label those. The third step is to draw currents. So let's draw currents for A. I'm going to draw this one going in, I'll draw this one coming out, and I'll draw this one coming out. And I'll label them I1, I2, and I3. If you're wondering, is there a node here? Yes, there is a node there, but we don't need to worry about it because we can put these impedances in a box, right, and call it 6 plus J8, right? That gets us from A to B, so we have the impedance between A and B. So now for node A, it says that determine the nodal equations and voltages at node A and B. Well, at A, if I do KCL, so I drew the currents, I label the currents, and I do KCL. Actually, I'll write it over here and say KCL at A. KCL at A is, right, sum of the currents in equals the sum of the currents out of node A. Well, what's going into A is I1. What's coming out of A is I2 and I3. Okay, there's the beginning. Now for each of these, if I know the current, I know the current. If I don't know the current, I do Ohm's law. Ohm's law is V over Z. I2, V over Z. I3, V over Z, right? And I1 is going from C to A. So VC minus VA over what's in between them is negative J20. As I mentioned earlier, if you wanted, your very first step on all AC problems is to just go label your J components, negative J20, J4, I already did J8 here, and that's all my impedances like that. I know VC, so I can write 30 angle 50 divided by, minus VA divided by negative J20. I'm doing this more like step by step. If you wanted to just put it all into your KCL equation, that would also be fine. But just to be clear as to where these are, I'm writing them separately. So this one I'm going from VA to ground across a J4. Well, ground is 0, so it's simply VA over J4. I3 is going from A to B, VA minus VB over 6 plus J8. So now at A, I can plug all of those in. 30 angle 50 minus VA divided by negative J20. That's I1. Keep the same equation as long as I drew my arrows. It doesn't matter which way I drew them. I just need to be consistent. From the tail to the tip. From VC to VA is what I did here. I2 is going from A to ground, VA over J4 plus VA minus VB over 6 plus J8. There is my A equations. B equations, we'll do them in green. I'm going to keep the same I3 because I already have it drawn. I3, this one, I'll draw it down. I4 and I5, I'm going to match mine as this arrow going up and just call this I5, is that 4 amps. So now if I'm doing KCL at node B, what's going in? Sum of the currents in equals sum of the currents out. Sum of the currents in, I3 is going in, and I5 is going in. I4 is coming out. I3, I already had on the other side, but I'll write it again. If you drew yours the other way, you drew a separate, I6 going from B to A, then the only thing that would change is I would subtract VB minus VA if you drew your arrow the other way. But then if I drew it the other way, that would also need to be on the out side of the equation, which is why it doesn't matter which way you draw it, because mathematically it means the same thing. I4 is going from VB to ground, going across a 2 ohm resistor. Well, ground is 0, so it's just VB over 2. And I5 is given, 4 amps, angle 90. And note, even if up here there had been a resistor, say right here, I5 that I have in that current source would be the same, because the current is going to be constant for those series elements, right? So if I had this in series, or say that there was, an inductor right here, and now this is still node B, it wouldn't matter that these two elements were here. I wouldn't subtract them, I wouldn't divide by them, because the current is the same still right here, I5. Okay, so with current sources, I know the current, just plug it in. I put all of them together, I3 VA minus VB over 6 plus J8 plus I5, 4 amps, angle 90 equals VB over 2. It asks to determine the values of these, and I will write them down. But on that video, if you go back and watch lesson 18's video, it discusses like the 4 different ways to do this of matrices, substitution. So if you want to give that a shot, you can.
Sir, on the exam, do you think they'll actually have us solve it out or just set it up?
Now I have to change my video because I'm not going to post, but no, we'll just ask you to set up an AC. We could ask you to solve for a DC nodal voltages, because you can do those with a calculator.
Yeah.
But you can't plug in the syssolve in with complex numbers. So.
Okay. Thank you.
Yep. If I was to do it by hand, I would multiply everything by negative J20 until I had everything on top on this side, and multiply it by J4 and multiply it by 6 plus J8. And then I would just let the calculator do the work on some of those things. I put it all on one side and multiply by those out till all my denominators canceled out essentially. And then I would plug in one of my VAs or VBs back in over here. That's the substitution if you're not doing matrices, for those of y'all that aren't math majors. The math majors, if you are a math major and you think that you can't do this, I think you're too late to change majors, but you should go get some help with matrices because you're a math major. So you should be able to do that. And I say that like in the fall, go find your advisor or whatever.